Welcome to this tutorial. I am explaining question number 11 of paper 2 May-June exam series of 2021. The topic of this question is detection of radiations. The question says a highly radioactive source that emits beta particles is placed a few centimeters away from a detector. So this is the radioactive source present inside a metal casing, and this radioactive source is emitting beta particles, and a detector is placed in front of it, which is obviously connected to a counter to show the count rate of the radiations as shown in the figure 11.1. State the name of the particle which has the same mass and charge as a beta particle. So the electron is the particle which has the same mass and charge as beta particle. State and explain why metal casing in 11.1 is used. So firstly, it prevents exposure to radiation and prevents radiations traveling in all directions. So this is the reason or the safety precautions that are made sure by using this metal case in this experiment. In part C, the question says state and explain what happens to the number of particles detected in a minute as the radioactive source is moved a few centimeters further away from the source. So when the source is moved a few centimeters away from the source, the count rate or the reading of the counter would decrease slightly. So the count decreases slightly, and the reason of this decrease is there would be some scattering of the particles, because the particles would spread out and the particles reaching the detector would be a little lesser than as compared to when the source was placed near the detector. And in the next part it says when we move the source more than 1 meters away from the source. So when the source is moved more than 1 meter away from the detector, then we have a large decrease in the count. So we observe large decrease in the count because beta particles are stopped by air for a distance of more than 1 meter. So since we have a large distance between the source and the detector, so the radiations emitted by the source would be absorbed by the air particles and they would be used to ionize the air particles. A nucleus of strontium decays by the beta emission of a nucleus of yttrium. Complete the decay equation for this decay. So for beta particle, the mass number is 0. The proton number should increase by 1 for yttrium because it is a beta decay, and the nucleon number or the mass number should remain the same in this beta decay. Nuclear fusion and nuclear fission both release large amounts of energy. Describe how the process of nuclear fusion differs from the process of nuclear fission. So in fusion, smaller nuclei come together to form a larger nucleus, while in fission a larger nucleus splits up into smaller daughter nuclei. So this is the main difference between the two processes, and this should earn 3 marks to us. Describe the condition needed for nuclear fusion to take place. So the first condition is this process requires high pressure, and without the high pressure this process is not possible. And second condition required is it requires a very high temperature for the process to take place and the nuclear fusion to occur. So the question ends with this part.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel, and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.